Shalom, giving all praises honor and glory to our power Yahweh. Bahasham Yahweh Shah, Bahasham Rachakwadash. The honestly apostles, the bishops, and the elders, great millstone. Peace and blessings to all who elect of the tabernacles of David. Scattered throughout the four corners of the earth, wherever you may be. Wherever you may be, to you I say Shalom, Yahshua, Shalom. All right, I'm going to try to be brief as possible because my phone is dying. But I did want to get this done, so maybe I can convert the video and upload it later this evening. These are, well, one of them was not so quick. It's about 8 minutes. There's actually more, but I didn't feel like they were necessary. I can mention real quick a couple other videos where, you know, robots, dealing with drones, robots doing factory work and stuff like that. But I want to get these three here, which two of them, the first and the third, are very similar, and then the one in between is something different. So this first one here is the Fibot. All right, refers primarily to a Chinese company that develops humanoid robots and the robots themselves. All right, the company has two main known models. Fibot M1, a full-size electronic humanoid robot, known for being the first of its kind to perform a completely independent human-like backflip. And that particular clip we're going to play after this was known as the Superman pose or Superman flip or something like that. What it was called, where he was performing. Which there ain't too many athletes that can do that. Okay. And there's a couple Jakes that I've seen do stuff like that. But Jake is Jake, right? But we're talking about robots. It says a full-size electronic humanoid robot, known for being the first of its kind to perform a completely independent human-like backflip. The M1 is marketed as the most powerful humanoid robot. All right, the most powerful humanoid robot. That's also why I had it doing the so-called Superman flip, whatever it was. It says the M1 is marked as the most powerful humanoid robot currently available, designed for physically demanding tasks with high torque density actuators and a substantial lift capacity. In other words, it's basically saying that it's strong as hell. Fibot C1. So that was Fibot M1, Fibot C1, a smaller, more compact AI-powered companion robot designed for home use, social interaction, and educational settings. It features a built-in projector and a friendly design aesthetic. Additionally, Fibots can refer to an unrelated open-source toolkit for prototyping robotic things using physical UIs. I'm pretty sure that stands for user interfaces, probably. And camera-based tracking developed by researchers including Jun Kato. Okay, look, there's more stuff coming up. All right. See. So yeah, the Fibot M1. Fibot C1. I'm not sure exactly which one this is, but we just want to generalize it as Fibot. So check it out. Alright, this next one here is called Skill Mimic. Okay, and this is a little 8-minute video breaking down to you what it's all about. But first, we're going to read it here. Skill Mimic is an advanced artificial intelligence, or AI, framework used to train humanoid robots to learn and perform complex physical tasks and athletic movements by observing human demonstrations. Okay, which is major when, especially when you go to a category like jobs, right? That's been a major talk, right? AI taking people's jobs, right? Or even when they're not taking people's jobs, they're commingling. So people on the job, but also robots on the job site. And it's becoming more and more prevalent because of Esau's world, all right, that we're living in, okay? It's like more like a welcome to the digital age type thing. I might even title it that. Key features and functionality. Learning from observation, okay? And the video is going to break it down to you perfectly. I think there's a demonstration about this robot playing basketball. Now, oh yeah, there's another one, because mind you, you have the robots. They look stupid. They need some more advancement. But you have the robots boxing, right? So now you got robots that are supposed to be simulating basketball or able to simulate basketball. So learning from observation. The system uses data captured from human performances via videos or motion capture suits, which like you'll see, how's the best way to explain it? Like you'll see, oh, perfect. You can use that because everybody likes that movie, Matrix, right? So with the Matrix, and not just the Matrix alone, meaning, they have the green screen, okay, and then they have a person wearing, like, I think it's usually like a black suit. It might be a black suit of another color, but it may be a black suit, and they'll have like these like white balls all over the suit to capture the body movements, okay, and then they can go back into the computer and you know draw up things, might be a robot or whatever the case may be, okay. So yeah, I mean, you have to look it up for yourself to get a better explanation, because I don't think I did it too much justice, because I know exactly what I'm talking about, but I don't know the best way to explain it. Um, but yeah, so it says the system uses data captured from human performances, all right, via videos or motion capture suits to understand the mechanics and nuances of a skill, such as dribbling a basketball or performing a jump shot, or try to do another example, like a video game. Okay, probably best fighting game ever, Tekken, right? Okay, so you take Tekken, and a lot of those moves that are used in Tekken are real moves. They get a person to perform the moves, okay, and they have a certain suit on that records the body movements, and then they put the character move. I mean, the real person's body movements into the character, and then they use real fighting moves. Okay, and of course some of those moves are made up, but for the most part, that's another aspect of trying to get you to understand what the motion capture suit is about. All right. So say you a boxer, you put on the motion capture suit and you do your best combo. It's going to record that. You can take that recording of your movement, and then well, in their case they're trying to put in a robot, right? So they take that movement, put it in the AI, or I mean, yeah, AI, same thing, robot, and the robot will capture your fighting combination. See, because you put on the suit to capture the motion. All right, so it's a simulation to reality, or sim to real. The initial movement policies are often pre-trained in a computer simulation. This allows the AI. I'm step on your little bug. I see this bug. It's harmless though. Figures run out later. Out later. Anyway, it says the initial movement policies are often pre-trained in a computer simulation. This allows the AI to practice thousands of variations until the motions are stable and robust. Once refined in this simulation, the learned policy is transferred to the physical robot hardware. See, that's what I was just trying to kind of explain to you. Handling imperfect data. Advanced versions like Skill Mimic V2 are designed to help robots learn smooth, flexible skills from sparse, noisy, or imperfect data. Oh, now I'm thinking about it come to mind, because everybody's making robots, right? Of course, they want to make robots to fight and stuff like that. Also, robot dogs. China has what they call a wolf pack, or wolf dogs, right, to try to assist them in battle. Who is it against? Taiwan. So this is where we're at in the digital age, okay? But this is the robot world of it. What we just read. I think I skipped something. Hold on, bear with me. All right, let me finish this. So it says advanced versions like Skill Mimic version 2 or V2 are designed to help robots learn smooth, flexible skills from sparse, noisy, or imperfect data. Versatile application. This framework enables a single policy to learn multiple skills, allowing for seamless switching between different actions, even if those transactions weren't in the original training data. Physical execution. When implemented on a physical robot, the AI system controls the robot's hands, manages its balance, and adjusts to real-world dynamics without continuous remote input. Applications and impact. Researchers, including those at the Hong Kong University of Science and Technology, or the HKUST, have successfully used Skill Mimic to teach robots to perform complex athletic feats. Now, this is where I draw up a question. If you can teach it to play basketball, do a backflip or whatever, what's stopping them from, computing up training simulations, all right? Making them do, like soldier type, mimicking, right? Um, it says they have successfully used skill mimic to teach robots to perform complex athletic feats such as dribbling, passing, and shooting a basketball. This technology is a significant step towards developing general purpose robots that can learn and adapt to different real world tasks simply by watching humans. Without requiring explicit programming for every specific movement. So they're very advanced at it. All right. And this is called the skill mimic. Okay. In this video here that we're going to play next, all right, is going to break it down for you. All right. So listen up.
We present Skill Mimic, a novel approach that enables physically simulated humanoids to learn a variety of basketball skills purely from human demonstrations. The learned skills can be flexibly reused to accomplish challenging tasks, such as layup scoring, which involves dribbling toward the basket, timing the dribble and layup to score, retrieving the rebound, and repeating the whole process. Basketball, as a collection of highly dynamic, complex, diverse, and precise object interaction skills, exemplifies the pinnacle of human athleticism and control capabilities. Most basketball enthusiasts, even without formal coaching, are able to master various skills from basketball demonstrations, such as online videos or real-world demonstrations. Similarly, can humanoid robots learn and reuse various basketball skills purely through imitation, just like humans? Our approach provides an efficient solution to this question. State-of-the-art methods in physics-based character animation apply deep reinforcement learning to mimic isolated body movements, combining these motion priors with manually designed skill rewards to learn interaction skills. However, given the complexity and diversity of basketball skills, designing skill rewards for each skill demands significant engineering effort. Instead, our method learns interaction skills using a purely data-driven approach, eliminating the need for designing case-by-case rewards. First, we capture the motion of real-world skill demonstrations to obtain data on human and object movements. By using deep reinforcement learning in physical simulations, we train the humanoid to interact with objects to ensure that the simulated movements of the body and objects are consistent with the reference data. To learn a diverse set of reusable basketball skills, we collect a large amount of basketball skill data using motion capture technology, including various styles of pickups, shooting, layups, and dribbling. We label these skills and, during the learning phase, randomly select skills and data frames from the dataset to initialize the simulation of the humanoid and the ball for imitation training. The core of this process involves designing a unified HOI imitation reward. In addition to a set of carefully designed kinematic imitation rewards, we also design a novel contact graph reward, significantly enhancing the robustness and accuracy of interaction imitation. For example, we define 3 contact graph nodes: the hands, exclusive body, and the ball, to form a simple contact graph to model contacts for diverse basketball interactions. Each node and edge store a binary value indicating contact or not. Our approach allows a single policy to master a broad spectrum of basketball skills, including various dribbling skills, scoring techniques, and other frequently used basketball skills. It is important to note that all skills are learned using a unified HOI imitation reward, and the same hyperparameters are applied throughout. The joint training of skills facilitates zero-shot switching between them. During testing, Flexible switching of skills can be achieved by manually providing skill conditions to the trained skill policy. Here is an example. As the amount of data increases, the robustness and diversity of the skills also grow accordingly. For example, a pickup skill trained with 40 pickup data clips can effectively generalize to situations beyond the coverage of the reference data. Once a skill policy has mastered multiple interaction skills, we can train a high-level policy to control skill switching to accomplish complex basketball tasks. Since the pre-trained skill policy has already mastered the basic interaction skills, simple goal-related task rewards can be highly efficient. The first task, throwing, involves throwing the ball to a specified height. The task reward is simply designed to reward the ball height to be close to the target height. After just 10 minutes of training, the high-level controller is able to flexibly switch between hookshot and rebounding skills to complete the task. The second task, named heading, requires dribbling the ball toward target locations. The reward for this task is straightforward, focusing on ensuring the ball remains close to these targets. After a brief training period of just 30 minutes on a single NVIDIA 4090 GPU, the high-level controller has demonstrated the ability to seamlessly switch among various dribbling skills to modify the dribbling direction as needed. Similarly, the circling task involves the simulated humanoid dribbling the ball around a specified point, maintaining a target radius. The reward function is designed to keep the ball as close as possible to the target circle, and it incorporates a velocity threshold penalty to discourage the ball from stopping. After an hour of training, the simulated humanoid is able to accurately dribble in circles, adhering to the specified center and radius. The scoring task is the most difficult one. The objective is to shoot the ball into a randomly positioned basket. Specifically, the task reward is composed of 4 parts: a velocity threshold penalty that discourages the ball from stopping, a heading reward that encourages proximity to the target basket, and a throwing reward that promotes high throws. These rewards have been discussed in previous tasks. Moreover, an additional bonus is granted when the ball is accurately scored. After approximately 2 hours of training, the simulated humanoid can efficiently dribble the ball toward the basket, execute layups at the right moments to score, secure the rebound, dribble away, and repeat the scoring process.
All right, so this last one is I think the name is Malclab, but I'm not sure um exactly because the first search pulled up something about some biochemical or something like that lab or whatever. So I typed in it again. I got a little something slightly different, but what we're looking for is down below. So, anyways, it says because this is that first thing they claim up. Malclab is if that's how you pronounce it, is a patented micro encapsulation technology for probiotics and has no association with robotics. All right, but then it says down below, Magic Lab or Magic Atom Robotics Technology. Okay, is a Chinese robotics company that develops, mass produces, and sells humanoid and quadrupedal robots. Okay, and you know what I immediately think about? Um, Ghost in the Machine or Ghost in the Shell. All right, which I mean they were the same series because the movie came from an anime series, Ghost in the Machine, Ghost in the Shell. All right, it was the same thing, but I think it was like a second. It's like a reboot, or not like a reboot, but you get what I'm saying. It was the same thing, but I was thinking about the movie. They had Henka Robotics and all that kind of stuff like that. It makes me think about that. So it says the robotics company is named Magic Lab, and its main product lines are called Magic Bots. Okay, so Magic Lab Robotics Company. Magic Lab specializes in embodied intelligence, technology, and general purpose humanoid robots for industrial and commercial applications. Oh, we put up a video some not too far back. I can't remember when it was, but there was two different ones, right, where it was just a head, but it looks realistic, okay? And then you had the actual robot that was walking like, I guess they programmed it to do that way, but it had like a model walk. And the people didn't believe it was a robot because it moved so smoothly. So the guy came and cut the robot open on stage to show that this is not a person in a suit. This is actually a robot. And when I say fluent, all right, because not too far back, the most fluent movement in robots used to be in what's the one? I always forget their name. Doggone, I had it on the tip of my tongue. Um, Boston Dynamics. Boston Dynamics. Go and check them out. Boston Dynamics used to have the most fluent robot movements, but that recent company that we talked about, when I say like human like, hey, this is what these people are creating. All right. It says flagship products. The company produces full-size general-purpose humanoid robots, such as the Magic Bot Z1 and G1 models, as well as quadrupedal robots. Oh, there you go right there. See, robotic dogs. Capabilities. The robots are known for high, and I believe these are all Chinese companies here. All three of these clips that we played. Their robots are known for high performance, strength, and mobility, and are designed for tasks in factories like product inspection, material handling, and warehousing. Beautiful, because we just talked about what robots that are working in factories. You got there's one article about a robot had bruises. His metal little hands were messed up for working in the factory X amount of time, whatever. Basically wear and tear. Well, that's what the humans were for, but that's the problem. The humans get old, the humans get weak, the humans get sick, the humans get pregnant, the humans get hungry, the humans got to be paid. But the robot, well, we can just go and give them new hands and put them right back out there on the assembly line. Anyways, the robots are known for high performance, strength, and mobility, and are designed for tasks in factories like product inspection, material handling, and warehousing. They can also run outdoors and navigate complex terrains. Technology. Magic Lab uses self-developed software and hardware, including advanced joint modules, motion control algorithms, and multimodal perception systems, or LiDAR cameras. All right, and that's that robot there. It's pretty much not doing too much in this last clip we're going to play, where it's also doing a flip, but it's more like almost like a capoeira type of flip, or as in that first robot, the Fibot, kind of did this straight Superman flip, whatever they call it, and then this one here is like doing like some kind of back flip slash capoeira type deal or whatever. This one right here looks like it's posing like Spider-Man. There's like prices on these things. See the prices on those things. So yeah, the Magic Lab Magic Bot G1 Standard Edition Humanoid. Okay, so with Esau, and in particular, these are these Chinese companies. But we know most everything stems back to Esau. But China's on a high level when it comes to robotics and technology and stuff like that. But what I was about to say is, I guess human life is not good enough for them. All right, the Lord didn't make a perfect specimen when He created human life, or commanded Yahweh Shai and Elohim to create human life, and everything was made good. But for these people, it's just not enough. All right, they got to take it to the next level. But that's pretty much it. I want to drop in those three little clips there that I saw earlier. Like I said, there were more, but I just grabbed those three. Yeah, I mean, what else to say? But welcome to the digital age. All right, and these are minor things, because what's major is Esau's system and his technology. But I know this is a different category, but I still want to drop a couple lines about these things because I saw them. So yeah. Because I mean, it's not like they're not making them; they are making these things, and a lot of them are taking people's jobs and
doing things. They're basically doing everything that humans can do. Okay, and we're trying to replace humans with robots, and then humans just living. It's like the Matrix movie, just batteries, right? Just living. Okay, getting your life from Esau or from universal basic income, but other topics. So, Lord willing, you will edify. Shalom.